Every time a program opens a file, reads from a socket, or writes to the screen, the Linux kernel assigns it a small integer. That integer is called a file descriptor. It's the only thing your program holds onto. No pointers, no handles, just a number. Let's unpack where that number comes from, what it points to, and why running out of them ruins your day. A file descriptor is a whole number. When your process asks the kernel to open a file, the kernel picks the smallest available integer and returns it. From then on, your program says read from 3 or close 7, and the kernel resolves that to the right resource. The program never gets a direct reference to the file or socket, just a number that indexes into a table the kernel keeps hidden from user space. Here's the chain. Your program holds a file descriptor number. That number indexes into a per process file descriptor table. Every process has its own. Each entry in that table points to an entry in the kernel's global open file table, which stores the current read-write position and the access mode. That entry points to the actual inode on disk. So read from FD3 goes through 3 layers of indirection before it touches real bytes. It sounds like a lot, but each lookup is just an array index, fast enough that you never think about it. Every process starts life with 3 file descriptors already open. 0 is standard input, where your program reads, typically the keyboard. 1 is standard output, where it prints results. 2 is standard error, a separate channel for diagnostics so error messages don't get tangled with your data. The kernel sets these up before your main function even runs. That's why the first file you open yourself gets assigned 3. Numbers 0 through 1 and 2 are spoken for. File descriptors are finite. Most Linux systems set a default per process limit of 124. Every time you open a file or socket and forget to close it, you leak 1. Leak enough and you hit the wall, the kernel returns an error, and nothing new will open until some are freed. This is one of the most common reasons servers buckle under load. A single connection handler that forgets to close its sockets can starve an entire process in minutes. You can check your limit anytime with your limit in and raise it if you need to. This script walks through the full life cycle. We call os.open with a read-only flag, and the kernel hands us a file descriptor, almost certainly 3, since 0, 1, and 2 belong to sting.out and std.out and str. We read 100 bytes through that number, then close it. After the close, the kernel reuses 3 the next time something opens. And that last line, listing procbd, is something you reach for constantly when debugging. Each entry in that directory is a symlink to the file or socket that descriptor represents. It's the most direct way to see what a process has open right now. File descriptors boil down to a number, a table, and a kernel doing the lookup. 3 layers of indirection, all of them just array accesses. Once you have that mental model, debugging too many open files or understanding how pipes and sockets work becomes much more straightforward. Thanks for watching. More on Linux internals coming soon on Awesome Linux TV.